This video is going to cover another example of determining the limiting reactant in some sort of reaction involving solutions. In this case, it would be not neutralization or precipitation since no precipitates form, but we still want to know what the limiting reactant is. So we're told 212 milliliters of 1.68 molar nickel 1 nitrate is mixed with 543 milliliters of 0.79 potassium molar potassium bromide. What's the limiting reactant? Alright, so step 1. Find moles, the number of moles of each reactant. We know that this is a limiting reactants problem because we're given data for both reactants. We're not only given it for one, we're given it for both. So that's got to be a clue in our mind to think, okay, this is a limiting reactants problem. So that's our first step. So first, we're going to need to find the moles of the nickel 1 nitrate. And then again, as we've seen before, we know that molarity or concentration equals number of moles divided by volume. Therefore, moles equals concentration times volume. It's going to go right back up in there. So we have 1.68 moles per liter. Again, we've seen in a previous example why I did that. Moles per liter and M are the same unit. Times 0.212 liters. And then if we multiply that on our calculators, we are going to get 0.35616 moles of nickel 1 nitrate. Alright, now we need to find the number of moles of potassium bromide. So we're just going to do the moles of KBr. Now that one we were told 0.79 molar, so moles per liter, times 0.543 liters. And that's going to equal 0.79 times 0.543, 0.42897 moles of KBr. Now, we still can't assume that either of these are the limiting reactant yet. We have to actually perform stoichiometry to know for sure. So this leads us to our second step. So using stoichiometry, compare the number of moles to the number of moles, or for consistency, let's just say to the number of moles of the same product. Using stoichiometry, we will compare the number of moles of each reactant to the number of moles of the same product. Now I'm going to pick the nickel bromide. We'll do that one. So first of all, we have to assume that each reactant is going to be limiting and perform stoichiometry as if it were limiting to be able to determine the actual true limiting reactant. So we'll set up our stoichiometry. So if we have 0.35616 moles of the nickel nitrate and the balanced reaction equation, that tells us that there is 1 mole of nickel bromide for every 1 mole of nickel nitrate, because you see in the balancing there it's 1 to 1. right? In case that wasn't clear, see there and there. So if there's 1 mole of the nickel bromide for every 1 mole of the nickel nitrate, then that means, again, the reason why we set up our stoichiometry this way is so that we would be left with units of moles of nickel bromide. So if the nickel nitrate were limiting, we would get 0.35616 moles of the nickel bromide. All right, now let's look at the situation as though the potassium bromide were the limiting reactant. So we have 0.42897 moles of the KBr, and then we'll set up our stoichiometry. So if we go into the balanced equation, we see that 3 moles of potassium bromide go into this reaction for every 1 mole of nickel bromide that comes out. So that means that 1 mole of nickel bromide can be produced for every 3 moles of potassium bromide. All right, so you can see in the balanced equation the 3-to-1 ratio there. And again, the reason why I set it up this way, this number on top, this number on the bottom, is because I want the units of moles of potassium bromide to cancel out, because that's not what I want. I already have that. I want to find the moles of nickel bromide. So when we multiply that by basically 1/3, we'll get 0.14299 moles of nickel bromide. So now we have to compare this number with this number. So since the concept of the limiting reactant means the one reactant which runs out first, whatever reactant gives you a smaller number of moles of the product you chose to compare it to, whichever one is smaller, that is your limiting reactant. So we'll look at these two numbers and see which one's smaller. So between this and this, it's pretty clear that this is the smaller number. And then what reactant did that go with? All right, potassium bromide. So that means because potassium bromide produced fewer moles of the product, what that means is that KBr is the limiting reactant. And the nickel nitrate is in excess. So again, we've seen this exact same concept before with different types of reactions. The only difference is now we're getting moles through C equals N over V instead of N equals M over MM. But we still need to start with a balanced equation. We still have to find the moles of each reactant. And then we use stoichiometry to compare the number of moles of each reactant, so nickel nitrate and potassium bromide, to the moles of the same product. The reactant which produces fewer moles of the given product is limiting. Since KBr produces fewer moles of nickel bromide, that makes potassium bromide the limiting reactant. So that's how we solve for that.